Welcome you all in the national webinar on higher education and research in natural resource management for environmental sustainability. We have been blessed upon with our chief guest and keynote speaker and eminent scientist of the country in the area of natural resource management, Dr. S.K. Chaudhary sir, Deputy Director General, Natural Resource Management, ICR, New Delhi. Also, we have with us Dr. A.K. Patra, President, Indian Society of Soil Science and Director, Indian Institute of Soil Science, Bhopal. Most respected Dr. K.P. Vishwanatha, sir, Honorable Vice Chancellor of Mahatma Phule Krishi Vidyapith, Rahuri, will chair this function. And also special presence of Dr. L. Farande, sir, Dean Faculty of Agriculture and Director of Instructions, Mahatma Phule Krishi Vidyapith, Rahuri, and Dr. Sharad Gadak, sir, Director of Research and Director of Extension, Mahatma Phule Krishi Vidyapith, Rahuri. Also, we have with us Dr. Sunil Gorantiwar, sir, Head Department of Agriculture Engineering, Mahatma Phule Krishi Vidyapith, Rahuri, and Principal Investigator of Center for Advanced Agriculture Science and Technology for Climate Smart Agriculture and Water Management Project and convener of this webinar. Dr. Mukul Shinde, sir, Professor of Soil and Water Conservation Engineering, Mahatma Phule Krishi Vidyapith, Rahuri, Co-Principal Investigator of CAST Project and Co-Convener of this webinar. Dr. Bapu Sahib Bhakre, sir, Head Department of Soil Science and Agriculture Chemistry and President, Rahuri Chapter of Indian Society of Soil Science, Mahatma Phule Krishi Vidyapith, Rahuri, and Organizing Secretary of this webinar. Dr. M.C. Ahire, sir, Dean, Punyashlok Ahilya Devi Holkar, College of Agriculture, Hargaon, Head, Department of Agriculture Extension and Communication, MPKV Rahuri, Joint Organizing Secretary of this webinar. Dr. N.J. Ranshul, sir, Secretary, Rahuri Chapter of Indian Society of Soil Science, MPKV Rahuri, and Joint Organizing Secretary of this webinar. All the associate deans, heads of departments, faculty, participants, all across the country, farmers and cast members, welcome you again. Now I request to Dr. Sunil Gorantiwar, sir, Principal Investigator, to brief about the CAST CSAWM project.
Yes, thank you very much, Dr. Nikam. But before that, I would like to request our Chairman and Honorable Vice Chancellor, Dr. K.P. Vishwanatha, to please say hello to our Chief Guest, Dr. S.K. Chaudhary.
Good morning and welcome, Dr. Chaudhary ji. Hope you are keeping well keeping fine in Delhi.
Yeah.
Delhi is, I think, safe now. Its condition must be improving.
Yeah. Condition is improving day by day, and our Cap 1, Cap 2, and Krishi Bhavan area is regularly sanitized.
Okay.
With the grace of God, we are all safe.
Okay. Nice. Welcome to this webinar.
Thank you.
Also, sir, Dr. A.K. Patra is also there. Yeah, okay. President, Indian Society of Soil Science.
Namaste. Good morning, sir.
Oh, namaste. How are you, sir?
I'm fine.
Welcome.
Thank you very much.
Nice to see you online.
You are organizing wonderful programs. Really, there is no words to express the appreciations.
Thank you.
Thank you very much.
Thank you. You are most welcome, sir. Please. Thank you.
Thank you very much, Chairman, sir, Chief Guest, and our guest of honor today. I think we can start the program now. Respected Chief Guest of today's function, Honorable Deputy Director General of ICR, Dr. S.K. Chaudhary, Honorable Vice Chancellor of Mahatma Phule Krishi Vidyapith, Rahuri, Dr. K.P. Vishwanatha, then guest of honor of today's function, respected President of Indian Society of Soil Science, Dr. A.K. Patra, then respected Dean and Director of Instruction, Dr. Ashok Farande, respected Director of Research and Extension Education, Dr. S.R. Gadak, all the associate deans, heads of the department, entire organizing team, including organizing secretary Dr. Bhakre, and also joint organizing secretary Dr. Ahire, and various eminent scientists from the NRM group. They have joined for this program. So all those scientists, faculties, and students. Okay. Let me take this as a brief opportunity to narrate about this project and also this endeavor of implementing the online training programs. Our project is on the Center for Advanced Agricultural Science and Technology for Climate Smart Agriculture and water management. We had submitted this project under the guidance of our Honorable Vice Chancellor, Dr. K.P. Vishwanatha, to a National Agricultural Higher Education Project of ICR, which is World Bank assisted program. And through the several round of presentation and scrutiny, we have been allotted with this project, and we are implementing this project under the guidance of our Honorable Vice Chancellor, Dean and Director of Instruction and Director of Research. One of the objectives of this project is capacity building of the scientists, farmers, faculties, and postgraduate students of this university, and also from other organizations and university all over India for climate smart agriculture and water management. We had been organizing several in-campus training programs, but because of this pandemic situation, all of us know that it was difficult to organize the in-campus or in-person training program. So we shifted for organization of online training program. So as soon as the lockdown period started, our Honorable Vice Chancellor advised us to see the possibility of organizing online training program, and he guided us also in organization of this. So as a result of this, over a period of almost 3 months, we organized more than 40 training programs and webinars. We reached to 12,000 students, faculties, and 5,000 farmers all over India. And still we are in fact organizing the training programs. We received quite a huge response. As per our data, about 75,000 participants all over India applied for our several training programs, but due to the limitations of our online platform, we had to select the number of participants to our limit actually. So this is one of our important objective, and we are trying to reach to the several stakeholders through this. Our other objectives are related to the education, to start postgraduate diploma that we have started, then to start the postdoctoral research in climate smart agriculture and water management, that also we have started, and to strengthen our postgraduate and doctoral program in context of climate smart agriculture and water management. Our third objective is to develop the tools and technologies based on remote sensing, GIS, that is geoinformatics, drones, robotics, the Internet of Things, mobile application, web-based applications. And we have made much headway into that. We have developed certain tools, IoT-based, to enable the farmers to adopt the precision irrigation water management technologies on their farm in real time. And our next important objective is to implement the concepts of digital villages and also the climate smart villages. And for that, we have selected 3 clusters actually, one for climate smart village, another for digital village, and next also for climate smart and digital village, in association with the different NGOs and also the different partners, including NABARD, BioF Water. So in this way, we are implementing the different programs under climate smart agriculture and water management. On this occasion, I would like to welcome all the participants and dignitaries who have joined for this program. Thank you very much.
Thank you, sir. Now I would like request Dr. Bapusaheb Bhakre, sir, organizing secretary of this webinar, to brief about the national webinar. So please.
Good morning, one and all. Dr. S.K. Chaudhary, sir, DDG NRM, ICR New Delhi. Dr. K.P. Vishwanatha, sir, Honorable Vice Chancellor of MPKV Rauri. Dr. A.K. Patra, the President of Indian Society of Soil Science and also the Director of Indian Institute of Soil Science, Bhopal. Dr. D.R. Bishwas, Secretary of Indian Society of Soil Science. All the heads of the departments, particularly Dr. A.L. Farandi, the Dean, Faculty of Agriculture, MPKV Rauri. Dr. S.R. Gadak, Director of Research. I see many of the scientists from the ICR institutes, they have joined, and so welcome you all. It's my privilege and honor to have an eminent soil scientist and Deputy Director General Dr. S.K. Chaudhary, sir, as chief guest of today's webinar and the keynote speaker on the topic of higher education and research in natural resource management and environmental sustainability. Indeed, it's also an opportunity for our aspiring students and the candidates for SRF, JRF, and ARS examinations. And this webinar was organized with this particular view that our aspiring candidates as well as the faculty should have an acquaintance of the research in natural resource management, as well as we all know that the NRM division under DDG NRM ICR is conducting basic and strategic researches to develop the technologies for conservation, management, sustainable utilization of natural resources, ensuring food, nutritional, and environmental securities in the country. It is a well-known fact that NRM covers a wide range of areas of research in integrated soil, water, nutrient management, watershed management, resource conservation technologies, crop diversification, IFS, dryland farming, and also on the abiotic stress management, climate resilient agriculture, conservation agriculture, and all these topics that it's a wide subject. And so, of course, to have an acquaintance of all these, particularly what the research is going on in ICR as well as the future plans in the natural resource management and the strategies to be, we all the faculties to be get acquainted with all these. So the person none other than the DDG, Honorable DDG, Dr. S.K. Chaudhary was the best person to have the keynote address on this particular topic of the higher education and research in natural resource management. So with this, we have also eminent scientists from all the ICR institutes who have joined this program. So thank you very much and welcome you all. Thank you.
Thank you, sir. Now I request to Dr. L. Farande, sir, Dean Faculty of Agriculture and Director of Instruction, MPKV Rahuri, to welcome and introduce today's chief guest and keynote speaker. Sir, please.
Okay. Can you hear me, please?
Yes, sir.
Can you hear me?
Yes, sir.
Yeah.
Okay,
yes,
fine.
Sir.
Yeah. Good morning to everyone. I extend my warm welcome to all. First of all, it is my privilege to extend warm welcome on behalf of our Honorable Vice Chancellor, sir, and all the faculties of our university to our beloved chief guest and keynote speaker, Dr. S.K. Chaudhary ji, Deputy Director General, NRM, ICR, New Delhi. I take this opportunity to introduce our chief guest and keynote speaker, Dr. S.K. Chaudhary ji, on this occasion of National Webinar of Higher Education and Research in the Natural Resource Management for Environmental Sustainability. Dr. Suresh Kumar Chaudhary is presently holding the position of Deputy Director General, Natural Resource Management in Indian Council of Agriculture Research, New Delhi. He obtained his bachelor and master from the JNKV Jabalpur and doctorate from MPKV Rahuri. He is visiting scientist and faculty to many European, Asian, and Australian institutes and has exposure of 37 countries across the continents. He started his professional career from IIS Bhopal and subsequently worked in a various scientific capacity in CRIDA Hyderabad, then DWMR Rahuri, IIWM Bhubaneswar, CSSRI Karnal, ADG Soil and Water Management, and now as a Deputy Director General NRM. He is a recipient of many prestigious awards and honors, including TWAS Medal of United Nations, ICR Rafi Ahmad Kidwai Award, ICR Team Research Award, NAS Recognition Award, and Salinity Excellence Award, Lifetime Achievement Award of the Institute of Engineers, IPNI and FAI Award, and 12th International Congress Commemoration Award of Indian Society of Soil Science. He is a fellow of International Centers of Theoretical Physics, Italy, National Academy of Agriculture Science, New Delhi, Indian Science Academy, Bangalore, then Maharashtra Academy of Science, Pune, Indian Society of Soil Science, New Delhi. He was the President of Indian Society of Soil Science, President of Indian Society of Agrophysics, and now he is a Vice President, Indian Society of Soil Salinity and Water Quality. And he has published more than 112 papers in reputed international journals, 132 research papers in reputed national journals, and 8 policy papers. He also authored around 12 books in the field of this natural resource management. He is currently leading countrywide natural resource management research that includes the climate change impact on agriculture, land degradation, arid and land management, integrated farming system, rainfed and irrigated agriculture, abiotic stress management and ecosystem restoration, and the management, and provided the scientific leadership in soil and water management research in India and in South Asia. He is representing India in FAO for a global soil partnership, global land degradation program, ASEAN soil partnership, then global water partnership, and he has worked working exposure more than 15 different countries. Thank you, Dr. Chaudhary ji, for joining us for this national webinar as a chief guest and accepting our invitation to give this keynote speaker as a keynote speaker during this webinar. I'm happy to welcome our Honorable Vice Chancellor, sir, and the chairman of this national webinar series, Dr. KP Vishwanath ji, who is the guiding force in organizing such online program in series during the lockdown period and always inspiration for us. I welcome you, sir. I feel privileged to welcome Dr. A.K. Patra ji, Director ICR Institute of Soil Science, Bhopal, and also the President of Indian Society of Soil Science, and he is a guest of honor of today's function. I also welcome all the directors, professors of different institutes of India. I also welcome my friend Dr. Biswat ji, Secretary of Indian Society of Soil Science at this juncture. I also welcome Dr. S.R. Gadak, Director of Research and Director of Extension Education of our university, for his special presence at this occasion. I also welcome Dr. S.D. Gorontiwar, convener and PI of this our CAST project, Dr. M.G. Shinde, co-convener of this CAST project, also Dr. B.D. Bhakre, co-PI and organizing secretary of this particular function, Dr. M.C. Ahire, Dr. N.J. Ranshur, joint organizing secretary, and all the program coordinators and all my team members of this CAST project. I extend my warm welcome to all the officers, associate deans, heads of the department, and the faculties of MPKV Rahuri. I extend my warm welcome to all my dear participants for showing their huge response in participation for this program. I congratulate to convener, co-convener, organizing secretary, course coordinators, and all these CAST team members for organizing this online national webinar on higher education and research in natural resource management for environmental sustainability. Once again, I welcome you all and thank you very much at this occasion. Thank you.
Thank you, sir. Now I request our today's guest and keynote speaker, Dr. S.K. Chaudhary, sir, to enlighten us. Sir, please.
Thank you so much. Thank you very much, Dr. Farande Saab, for such a nice introduction. I do not know whether I deserve it or not, but certainly speaking to you from the core of my heart, it is always a great pleasure to visit this university and talk to you all and to see your faces there. It gives me great energy. It becomes a great source of inspiration for me. And I always draw inspiration from every particle of this university, because I consider myself highly fortunate to be a scholar of this university. And always I got so much so from this university that I don't know I will be able to repay it in this birth or not. And that's why right in the beginning, I would like to tell to all the participants that I want to dedicate today's lecture to my own university, that is Mahatma Phule Krishi Vidyapith Rahuri. Dear friends, with this positive note, I will start my presentation. And as said earlier, this presentation is on environmental sustainability, learning the lessons for research and education, taking higher education in NRM disciplines. This is the broad purpose of today's lecture. While preparing this lecture, many people, they helped me. And I find many of them present in today's gathering. My worthy Vice Chancellor and the great leader of the university, Dr. Vishwanatha. I'm really thankful to you, and I would like to put on record my words of appreciation for making so much so during the lockdown period. If you see the brochure, I saw the brochure, completely read it, and I found so many activities in one single program of CAS. All the other universities, university departments, they are making effort, that is different. But single program of CAS, Center of Advanced Studies, it has done so much so, not only for the state of Maharashtra, but for the whole country. And I find today there are so many students joining this gathering. Dr. Ashok Farande, he's a dean of the university, but more than that, he's a very close friend, but more than that, he is also a good teacher for me. Dr. Ashok Lakshman Farande taught me the clay mineralogy. And the way you taught, Dr. Saab, I cannot forget it. Those structures and all, everything is there in my mind, and that percolates down whenever I discuss anything with clay, humus interaction or clay water interaction or interactive forces, van der Waals forces, everything that is still in my memory. I cannot forget those things. Also in today's gathering, another good friend is Dr. Sharad Galak, the director of research, and all senior authorities from the university side. My very good colleague, the director of Indian Institute of Soil Science and president of Indian Society of Soil Science, Dr. Ashok Patra. He was very keen to attend this lecture. And not only that, he has provided some input for my slides also. Dr. Deepak Ranjan Biswas is the secretary of Indian Society of Soil Science. They are the office bearers of the society, and they are taking the society far ahead than what is required in this country. The other colleagues from the university, Dr. Bapu Saheb Bhakre, the head of Soil Science Division and very, very close and intimate friend of mine. Dr. Mukund Shindeji is there, and also the office bearer of local chapter of Indian Society of Soil Science. Over and above, another good friend is there, that is Dr. Sunil Digambar Gorantiwar, who is always keen to arrange this kind of lectures. And he always keep discussing with me so many things. And this today's lecture is also an offshoot of that kind of discussion. And whenever we meet, we used to keep discussing so many technical and non-technical issues. And he's a very, very long duration friend or well-tested friend or the time scale. Dr. Gorantiwar, Dr. Bhakre, all these are great people. And great people makes institutions so great. So that's why my association with you, my association with this university is wonderful in the past, and I hope for the same in future also. Dear friends, today's lecture would be a little bit lengthier one. Normally, I prefer to speak for 20-25 minutes, all you know. But today I will speak at a bigger length because as Dr. Gorantiwar, Dr. Farande, they used to expect from me that I should speak something for the students, something for the research fellows, and come up with some good quality data. So my student friends and research fellows, be attentive. This presentation is having a lot of information, and much of that information will be of great use to you, not only for ARS examination or MPSC, but also for your professional growth in the areas which you are learning in the university. It's not only soil science or water management. It is much far beyond that. NRM doesn't limit itself to soil science and water management. So, dear friends, if you all agree, then I will start my presentation using some of these slides. And slowly, I will go with the slide one by one in the areas of soils and waters and then climate. And you know, all these are important parts of NRM research. Friends, yeah. When we talk of environmental sustainability, just I will keep it down. Yeah. When we talk of environmental sustainability, we essentially talk of something for the next generation. And it is not the individual or this era's problem. We have to be very, very visionary in keeping our ideas very clear for the next generation as well. And it has various components. Essentially, the key principle, they are surrounded with these 5 things. That is intergenerational decisions. Then targets. The target cannot be welfare of the present generation. And it cannot be welfare only for the gross domestic profit or GDP of the country. We need to think much beyond that. And this is the key principle. And this says that natural resource management cannot be viewed from the GDP all alone. Soils, they are not made only for growing the crops. Water is not only made for irrigation. There are so many other things. The climate is not only related to the crop and horticulture, growth and development, livestock and fisheries. It is much beyond that. The nature sector, the people sector, and whole as ecosystem and environmental perspective, when we look at it, then we get a different dimension of the whole problem. Then avoiding excess pollution, whether it is excess use of agricultural input or excess use of fossil fuel or excess burning of the fields or pollution due to any reason or excess industrialization coming more and more affluent to the agricultural fields. Therefore, the protection of the health, not of animal or humans, but the whole ecosystem. And here comes the One Health concept. When we talk of One Health, Honorable President of India, he also spoke about One Health, and Honorable Prime Minister of India, he also speaks about One Health. When we talk of One Health, because health is linked with one each other, you cannot isolate one from the other. Therefore, protecting health of the ecosystem becomes the responsibility. For that, you want environmental sustainability. Now, we are talking of the energy. And energy from renewable or non-renewable sources, we know very well, everything has a limit. Therefore, we need to shift for the more and more greener resources from the gray resources. While doing so, we need to come across so many processes. And these sustainability principles are standing on 3 pillars, and these 3 pillars are social, environmental, and economic. The environmental pillars, all these 5 things we discussed, these are coming from the environmental pillars. Then, since we are the social animals, the social responsibilities are there, whether you are working in private sector, working in public sector or corporate sector, wherever you are working, you have social responsibility. And all these activities have economic consequences. It impacts the economics of the country or economy of the country. When you are talking of making India a 5 trillion economy, then you cannot do by compromising any of these things. You have to align all your program, all government programs and non-government programs within the given scenario of environmental sustainability. And therefore, we can no more afford to do the over and non-judicious exploitation of natural resources, which we are not thinking at present. Where X amount of water is required, we are adding more and more X plus 1 plus 1 plus 1, we are adding to it. And that is creating a lot of trouble. When X grams of fertilizer is required, we are putting X plus 1 plus 1 plus 1 fertilizers to the crops. That is making not only soil pollute, but it also pollutes the groundwater. It also grounds the runoff which is going, and the nutrient loss which is occurring, it carries a lot of phosphorus along, and it creates lot many problems. Now, in today's lecture, we will take only limited areas, but right in the beginning, I would like to tell here for the use of the students who are sitting here or young faculty members, that when we talk of NRM research in this country, we essentially talk of the following things. whether it is land resource unitarization, characterization, or coming up with the land use plans. Then integrated water management, including wastewater management or wastewater utilization, including the watersheds. Then bio-waste management, and management of problematic soil, whether saline, alkali, acid soils, or waterlogged soils. That means in depth and dimension, we discuss and we deliberate and we research on the different degradation processes which are happening. The water conservation, including participatory watershed management, the present day Pradhan Mantri Krishi Sinchai Yojana, which is offshoot of this program. Then we talk in terms of crop diversification in the areas where a lot of water congestion is there, where in the areas where no diversification is possible, can we do some NRM manipulation so that we can go for crop diversification? Is also one of the research priority for us. The integrated farming system and organic farming. Country is moving forward in this direction. Then there is always imbalance between irrigated versus rainfed sector. Now, for last 2-3 decades, we used to say that India has 60% rainfed area and 40% irrigated area. The 60% production comes from 40% area and 40% production comes from 60% area. This was our logic earlier, but now it becomes a plain ground. Now we have 50% rainfed area and 50% irrigated area. In last 5-6 years, a lot of addition in irrigated area has taken place. And this has happened only because of the increase in the area under micro irrigation. Then important point is climate resilient agriculture, on which we are researching these days too much, with abiotic stress management and climate resilient agriculture. All edaphic, pedological, edaphological, all factors, the climatic factors, everything we take into consideration. Agroforestry, weed management, these are our traditional areas of work in NRM. Other than that, the challenged ecosystem, hill agriculture, coastal agriculture, and arid land agriculture. Arid land, when we say arid ecosystem, we have deserts one side and we have cold deserts another side. Leh Ladakh is a part of cold desert. That also we are taking care. And the western part of Rajasthan, where Thar deserts are there, we are doing research there also. If you are able to enhance 4 or 5 centimeter irrigation water in those areas, it makes miracles. If you are able to conserve irrigation water worth for one irrigation, that helps the doubling income in those areas. And that is not support only for agriculture, but it's a great support for livestock, the small ruminant. They can feed in these areas. So these are the research priorities in which NRM research is happening, whether ICR Institute or state agriculture universities, all higher education and all research is being done in these areas. I have summarized these areas here. In today's presentation, I cannot take all the areas together, but important amongst them, what are the recent priorities in soil research? What are the priorities in water management research? What are the priorities in climate research? How they are linked with each other? How the frontier research areas can help us to come up with the future education programs in these areas? Because we know some of the areas which were studied earlier, now in agricultural education, those courses have disappeared completely. A few moments back, when I said Dr. Ashok Prande has taught us clay mineralogy, that clay mineralogy is vanishing. It is not being taught anywhere. The exclusive course on clay mineralogy slowly disappearing. And such basic information, if we are missing in education, probably will not be able to develop good soil scientists in future. If you don't study the basics of hydrology, probably you will not be able to generate very good water management scientists in future. If you don't understand the simulation modeling programs and simulation modeling processes in climate change research, then you cannot have good climate change scientists in future. Therefore, we'll be taking a few areas of this in today's presentation. But before we enter, I would like to tell to the young generation that the NRM has given to this country so much so. It is not that today I'm DDG, that's why I'm speaking so. I remained in these divisions right from the beginning. When I joined in 1990, Since then, I'm working in natural resource management area. Therefore, for last 3-4 decades, I have seen all the changes, all the transformation that happened in the area of natural resource management. The bioengineering measures of soil water conservation, we reclaimed, improved roughly 58 million hectare area in this country, whether it was through NWDRPA, or earlier program, or Integrated Water Management Program, or Pradhan Mantri Krishi Sinchai Yojana. All this input came from the state agriculture universities and ICR together. Jointly, we have given technical backstopping, and we helped country in reclaiming 58 million hectare area. The salt affected soil to National Mission on Sustainable Agriculture, 2.7 million hectare. Now this figure is almost 3 million hectare. 3 million hectare area in saline soils, sodic soils, or acid soils, not acids, saline and sodic only together. If you see, it comes to 3 million hectare. Then waterlogged saline soils, which are roughly 2 million hectare in this country. Out of that, we are working on 1.5 million, 1.5 lakh. So roughly 3.5 million hectare is waterlogged area, but this is waterlogged saline. Then resource conservation technology, already 2.5 million hectare has gone. And we say conservation agriculture is now roughly touching to 3 million hectare area. These are some of the important technologies I have mentioned. Otherwise, the NRM contribution, if you talk of the soil management, you talk of all 140 million hectare area. If you talk of fertilizer management, you essentially talk of 140 million hectare area. When you talk of irrigation management, you are talking for a whole irrigated area. Therefore, NRM technology is not point technology, it is a regional scale technology, and all the technologies are being developed and implemented through participatory approaches, through community approaches, through mega government programs. These developments are happening. And this credit goes to all the scientists of NRM who are involved not only in research, but also in teaching, and their contribution in bringing forward such a huge important input to the country's development. Coming to sustainable development goals. Many participants are raising hands. All participants, I will request, please send your questions to the organizers and write the correct question. At the end, we'll spare some time for discussion as well. So when we talk of sustainable development goals, you are listening these things for many years together. SDGs, in 2015, the United Nations, when they set agenda for transforming our world, they have given 17 sustainable development goals. And each goal has some sub-goals, and all sub-goals are having some actionable points. These action points are the guiding principle for future global developments in agriculture or non-agricultural sector. So within that, we find that many of the goals, they are directly related to the NRM research. The 17 SDGs that are mostly focusing on end of poverty, fighting inequality and injustice, and tackling climate change by 2030. So this is a big agenda. And for India, achieving these SDGs are very crucial because we have our commitments for Atmanirbhar Bharat. We have our commitments for doubling farmers' income. We have our commitments for reducing 25% dependence on the mineral fertilizers. We have our commitments for enhancing the area in micro-irrigation. We have our commitments in developing more and more and reclaim more and more wastelands and bringing that to agriculture. So with these commitments, what kind of intensive efforts are required that one can imagine? Dear friends, when you want to walk on this path, let us understand the challenges. Briefly, I would touch here, but later on in subsequent slide, we'll discuss in detail water scarcity. The graph I have given in between is very well-known graph to all of you. The water scarcity level at 1000 cubic millimeter, 1700 cubic millimeter is water stress level, and India has already crossed the line of 1500 cubic meter. So it has already entered in the arena of water stress area. Water availability, additional water is not going to come from anywhere. You have your own quota of water. You have limited freshwater resources. You have limited groundwater resources. Within that, you have to manage. At the most, you can bring some wastewater for bringing in the agricultural use. That you can do. Now, degradation on one hand, climate change on the other hand, and soil quality. These are the major challenges. How they are limiting the agriculture growth and development, that we will see. But our agriculture, when I say agriculture, I essentially speak of crops, means field crops, as well as horticultural crops. The livestock, whether big ruminants or small ruminant. Fisheries, whether inland fisheries or marine fisheries. All these sectors, they are under threat. I'm really not making unnecessary hype of all these things. I am giving you the real clues and clips, what is happening today and how it is happening and how we can combat it, how we can overcome it. The subsequent slides we'll see. Then coming to another story, when we talk of SDGs, Sustainable Development Goals, let us have a small relook on the India's commitments. In United Nations Convention for Combating Desertification, popularly known as UNCCD, all of you are aware. In UNCCD, India has committed that we will reduce the gases emission by 25% by 2030. This is one commitment. Understand? And this commitment is a very big commitment. Although major emissions are not coming from agriculture, but whatever is coming from agriculture sector, we can still reduce it, and we are committed to that. Then COP14, which has happened last year. UNCCD's COP14, those who are alert and aware in climate research, they know COP14 is the Committee of Parties 14 under UNCCD. And India is part of this party. When say party, party means so many countries. And in this COP14, which happened last year, we have committed that we are committed for land degradation neutrality. When we say land degradation neutrality, we essentially mean that we want to neutralize the rate of degradation and rate of restoration. We want to equalize the rate of degradation with the rate of restoration. Means whatever degradation that happens, we will restore the same amount of area or similar area in cultivation. Area going out of cultivation and area coming in the cultivation. We want to make them equal. Now just visualize. On one side, you have this commitment. On the other hand, we are creating a lot of infrastructure in this country. Very big roads. Many of us, we are the children from rural background. We have our own lands in our villages. We know the roads are widening. The bigger roads are going and many outer bypasses are coming up. In those outer bypasses, a lot of good cultivated land is acquired by the government. And we still say we have 141 million hectare area. 10-20 years back, we said we have 141 million hectare area. So this needs really serious thinking. If that is the case, then want to revert and want to equalize the rate of degradation with the rate of restoration, then where the land will come from? This is one question. Now, restore land and sustain future was the mantra of last year's COP14 meeting. In that, we said that we will achieve the land degradation neutrality by 2030. So SDG target of achieving land degradation neutrality by 2030. And we committed from 21 million hectare, we will reclaim area up to 26 million hectare. Now, making 21 million hectare to 26 million hectare, we have 10 years time. And our commitment is additional 5 million hectare area. 5 million hectare area in next 10 years. Means every year, how much area? You can imagine this much area we need to reclaim and bring into normally reclaim them and make them normal soils. So this was Delhi's declaration, in which not only degradation, but the other problems like drought and the other climatic risks need to be neutralized so that farmers do not get affected by this. How we'll do this? For that, I have given some action points. How to achieve this land degradation neutrality. Adopt SLM, that is Sustainable Land Management Solutions. Adopt these sustainable land management solutions for agriculture, food, forestry, shelter, and energy. It's not only agriculture, but since we are dealing with agriculture, we can limit ourselves to agriculture all alone. So sustainable soil management in that case will be the only solution for us. And that is why Government of India is putting so much emphasis on sustainable soil management, whether it is through PMKSY or whether it is through soil health management program. Then second action point, which is possible, that is scaling solutions for conservation and restoration of ecosystem services, whether soil, forest, and water. But unfortunately, when we treat soil, we absolutely treat soil only from the viewpoint of crop production. We do not visualize that soil has so many other functions to perform, what we call the ecosystem services. One ecosystem service may be providing food for you, but other ecosystem services, there are so many in numbers, and those functions are to be done by soil. So unless you bother for soil quality, not only soil health, unless you bother for soil quality, you cannot scale up the solutions for conservation and restoration. Similarly, providing resilience through improved livable opportunities, addressing food loss and food security. Anyway, NRM has very limited role to play in this, but still we can provide the climate resilience by which we can do this. The climate smart agriculture through carbon emissions and adaptive capacity, enhancing adaptive capacity. And how can we do that? Directly on-farm demonstration on the farmer's field, showing the climate resilient technologies and creating more and more awareness amongst rural youth and entrepreneurs how to go for the climate change adaptation programs. Biodiversity. When land degradation is happening, it is not only land we are losing. It is not only nutrient we are losing. The biggest loss is happening because we are losing the biodiversity. The kind of biodiversity we are losing through runoff, through many displacement processes, in deserts, in hills, a lot of diversity we are losing. And that's why the loss of diversity is irreparable, non-recoverable. And we need to give emphasis to this. And this is the least studied area. In soil science, in natural resources, in higher education, we do not study biodiversity the way it is required. In soil science, how many of us we are aware of microbial biodiversity? Probably we have not given due emphasis to this subject. Similarly, science-driven governance for risk management and environmental restoration. In India, unfortunately, we do not speak anything on this. But if you go in Australia, if you go in European countries, if you go in Latin America, even parts of Africa, they started speaking on this. How you equip your governance system of, it's not government, I'm talking of governance. What is your preparedness for governance for risk management? It is not that insurance program nikal diya aur kaam ho gaya. It is not so easy. Insurance can provide some support to the farmer, but it's not the complete risk cover. It is not the foolproof risk mechanism. So what is the risk mechanism? Providing alternatives. If A plan is failed, your B should be ready. If A and B fail, your C should be ready. What we are proposing in our district contingency plans is this. If this fails in this week, then next week you are supposed to do this. So this kind of support is not there, and this is required, and this is to be done by ICR, agriculture universities, and all our young boys and girls. They can understand this very well, and this is very important program for the future. When we talk of different challenges of land degradation, let us understand what we mean by degradation. In India, out of 330 million hectare geographical area, India's geographical area is 330 million hectare. Out of that, 141 million hectare is cultivated. And within 141 million hectare, 104 billion hectare is affected by one or the other kind of land degradation. Some of the important land degradation forms I'm putting in front of you, like soil erosion happening roughly 75 million hectare area, wind erosion in arid zone, roughly 12 million hectare area, salinity, alkalinity, just see 6.73 is our old figure, but this must be roughly 10 million hectare now. The soil acidity, although area is 25 million hectare affected area, but 10.7 million hectare area which requires immediate solutions. The annual soil loss because of the soil erosion and the nutrient loss, I have given some figures. These are very important figures. You can take a snap of this. Average soil loss, the physical constraints also, and the crop production losses which are happening because of different problems. On the last line, I have written the crop production losses. If you do not avoid the water erosion, you are losing roughly 13.5 million ton food grains every year. If you don't want to correct soil salinity, then you will be losing 5.7 million ton food grain production every year. Similar are the figures for alkalinity. The alkalinity is 11.2 million hectare. Wind erosion, roughly 6.7 million hectare. So million ton, sorry, this much food grains you are losing. Within that, if you talk only and only of soil health, what are the points happening? What are the things happening? What are the threats? It's low soil organic carbon, multi-nutrient deficiency, low nutrient use efficiency, low fertilizer response ratio. All these things in many lectures I used to speak. I will not devote much time on this. But what are the actionable points? This is very important. Right side, that blue table, it shows these are the 5 actionable points which if we take care through our higher education, through research, through development, then probably we'll be better meeting the challenges and we'll be better combating the challenges of climate change. Number 1, monitoring land degradation. The figures I have shown here, they were collected roughly 10 years back and then harmonized through different agencies. Unfortunately, we do not have a single agency who does this. NRSC used to do by its own way. The CSSRI will be doing its own way. Forest Service of India will do its own way. Then CSSR, another institute, Dehradun, it will do its own way. Universities will do its own way. But we do not have any harmonized or single window system in this. In 2010, the National Academy of Agricultural Sciences brought up one publication, the Harmonized Land Degradation Map. And through that, we have given these figures. These figures may be much bigger figure right now, but would not have any estimates. So monitoring these very regularly would not have a mechanism. Like every 10 years, we go for population census. We do not have census or do not have any system of monitoring degradation continuously. And we have committed for land degradation neutrality. Therefore, there is a need to restore such kind of system. Improving soil health, another commitment, and a lot of things we do in this country. Managing crop residue, which is going out of the field or burning, that needs to be recycled. Then reducing carbon footprint in every intervention. We need to come up with the intervention which are carbon neutral or footprint is the minimum possible footprint. There's soil contamination, which is completely ignored. And my request to all the faculty members, all the scientists, those are teaching in universities, soil science, please give due weightage to soil contamination, soil pollution. These are the problems of future, but unless you prepare from today, you will not be addressed this problem in future. In future, I may not be DDG, you may not be faculty, and these students may come forward and they may blame that you did not teach us this that time. So soil contamination, soil pollution, these will be the area which will be coming. You see the soil fertility states of Indian soil. Soil fertility status. This graph I have shown you earlier also, those students, and in many of my lectures I show this. If you see the nitrogen, we have together, this low and medium together, it makes deficient. High is sufficient. So low and medium, if you sum them up, for nitrogen, it comes roughly 95%. For phosphorus, again, roughly 95%. For potassium, maybe close to 50%. So this kind of deficiency is there. In the case of micronutrients, we can just see percent sample deficit. Now, zinc deficiency, the iron deficiency, and in some areas, only few areas, copper and manganese, but zinc and iron. And another element is boron, and another element is sulfur. So these are the elements which are making agricultural production questionable. This requires immediate replenishment. Multinutrient deficiency, you know this, just when 50s we started fertilizer use, only nitrogen was deficit. After 10 years, along with nitrogen, iron was observed to be deficit. In 70s, then 5 nutrients deficit. 80s, that was added with 2 more nutrients. 90s, another 2 nutrients. Likewise, now we have these many nutrients deficit in our soil, and multinutrient deficiency is reflected in many ways. It's in infestation in different forms. The poor quality grains, food grain, the total enrichment which is required, the mineral nutrition which is required from our food is not being released and realized, and that is the problem which is happening because of the multinutrient deficiency. Dear friends, this is the graph I have deliberately put here. You can find it from the Fertilizers Survey of India or Fertilizer Scenario of India or FAI's book, Nutrient Consumption Pattern. When we started using nutrients in this country in early 60s, that time, Britishers, they used to teach us, some experts, they used to teach us that use this fertilizer, productivity will increase because productivity was very low. Over the period of time, productivity has gone up. The fertilizer consumption has gone up in a bigger rate. And subsequently, after 2010, there was a decline in fertilizer consumption to some extent. This is because of some policies. That time, sudden rise in phosphorus and potassium fertilizer was there. That's why potassium phosphorus consumption was very less. The phosphorus fertilizer prices increased. And subsequently, because of different policies, there was a variable change, variable trend in the fertilizer consumption. What I want to impress upon you here is, overall, if you see the fertilizer consumption is not very high. For the intensive agriculture which we are doing in this country, consuming 150 kg of fertilizer or less amount of fertilizer is not a big amount. Understand? What is the problem? The problem is the proportion of nitrogen which is being consumed, it is out of proportion. Total amount is out of proportion. Normally we say that ideally the ratio should be 4:2:1, although ICR doesn't advocate this ratio. We always suggest the soil test based prescription, but the ratio of 4:2:1 is not met out. And the consumption of nitrogen is huge. Of course, for this, policy is responsible. We have a nutrient-based subsidy policy, which is implemented on phosphorus and potassium, but urea is kept out of this NBS policy because of some other reasons, some political reasons. So unless we bring urea in NBS regime, this ratio cannot be corrected. So this graph shows the nutrient consumption pattern. In next section, we will have some more slides on fertilizer because at that time I will be discussing with some more other context. But what happens because of such imbalance, because of the overuse of nitrogen, it immediately affects the soil microbial biodiversity. When we say soil microbial biodiversity, what do we mean by that? I said that this subject is least studied subject in Indian soil science community. And this needs to be understood very well. When we talk of microbial biodiversity, the molecular soil ecology, it suggests what kind of diversity is present in the soil. Whether it's a bacteria, fungi, actinomycetes, algae, or protozoa, numbers are given here. In terms of number, in terms of biomass, gram per cubic meter per square meter of soil. So in 1 square meter area, how many grams of this diversified microorganisms are present? Similarly, if you talk only of the bacteria, their relative abundance, if you see whether it is proteobacteria or actinobacteria or acidobacteria, planktomycetes or chloroflexi, all these things, they are present in abundance. Such abundance is responsible for almost all kind of transformation that those are taking place in rhizosphere. Immediately below the root zone, their presence is must. Unless they are present in such huge, the huge numbers and huge biomass, they will not be able to provide due support to soil to perform its processes or perform its ecosystem services. Such an attempt was made by Indian Institute of Soil Science, and they brought a global atlas of metagenomics of diversity of dominant bacteria found in soil. And if you see in different ecological clusters, whether high pH, low pH, drylands, irrigated conditions, high electrical conductivity, or high solute concentration, variety of conditions, you will get variety of bacteria in different situations. And this balance is imbalanced if you use excess amount of fertilizers or excess amount of pesticides or excess amount of agrochemicals. So excess amount of agrochemicals, it disturbs this balance, which makes all inappropriateness in soil. When we talk of soil health, if you see the present day soil health card, are we addressing this? Anywhere if you find it? Anywhere in our understanding of soil science in India, do we find this? Probably no. We do not give proper justice to this, and this is one area in higher education which needs to be taken up immediately. Similarly, if this is the problem, then how to manage it? Now, graph right side, one arrow is there, one triangle is there. It shows from low soil biodiversity to high soil biodiversity. Original agriculture which was performed on Indian soil, it has very high soil biodiversity. And when it goes to lower side, automatically GHG emissions, the leaching of nutrients, happening of erosion, poor clay humus interaction, low retentivity of soil, these type of processes, they are enhanced. And if you want to make better biodiversity in the soil, then you need to go for some interventions which are given left side. Soil structure and porosity. It's a regulation. And its regulation, it regulates the ecological processes inside the soil. Water and nutrient availability. Automatically it doesn't work. For that, you need to enhance the soil organic carbon content in the soil. That you cannot do in a year or two. You require very wisely choose the cropping systems, wisely go for the integrated nutrient management. Then regulate the microclimate in such a manner that enough time is available for respiration inside the soil, and also not much stress is experienced by the rhizosphere. This happens only if you go for mixed cropping, intercropping, crop diversification, this kind of techniques, agro-techniques, then some kind of land modification, some kind of watershed development programs, some kind of bioengineering measures that really help correct the biodiversity balance in the soil. Balanced fertilizer, manuring, these are some of the traditionally done practices. And then once this soil biodiversity is restored, then you can expect better ecosystem services like carbon sequestration or environmental sustainability, what I was talking in this slide number 1. But if you want to enhance it, the immediate steps, the improvement of soil structure, minimizing nutrient losses, and correcting imbalance of the microbial community inside the soil. I was talking of remediation or soil pollution or soil contamination. This slide I'm deliberately putting in front of you. If I want to sensitize you, this is the area of future research. The future higher education in NRM is to happen in this line. Really, if you want to have sustainable environment or environmental sustainability, this is the one key principle. Use less and less to produce more and more, so that you do not pollute the whole environment, soil environment, and whole ecosystem for that matter. A state of soil which is harmful to organism due to presence of toxic pollutants. This is the simplest way we used to define the soil pollution. And what type of pollutions? Heavy metals, metalloids, radionuclides. Then polycyclic aromatic hydrocarbons, which are dumping, we are everyday dumping on the soil. Polychlorinated biphenyls, pesticides, herbicides, antibiotics, hospital waste, everything is being dumped on the soil. Although they say we are collecting in one place and we are incinerating, but ultimately it is soil which is getting affected. Air and soil, only these two terrestrial bodies which are getting affected. Pharmaceutical compounds, which are very difficult to degrade. Even if they go inside our body, within the body, because of the biological system, it may decompose readily, but inside the soil, decomposition is not possible. Such compounds are very difficult. And finally, the e-waste. Lot of computers, lot of mobiles, lot of hand tablets and all. After use, we used to throw. We don't go for repair of the computers and all. We throw them. Where do they go? Ultimately, this e-waste is being dumped somewhere in the soil. So this will be the biggest area of research in coming future. The remediation, when we talk of remediation, bottom right side, I have given a flow diagram which shows what are the processes involved in remediation. Remediation is not that easy. The process itself shows what kind of complexity is there. One leads to other, other leads to third. Under such complex system, remediation is not possible. The best way, you produce less and less pollutants. That is the basic mantra of this. And this is happening. Biodiversity loss is there, groundwater contamination is there, productivity is already affected, and now it is reaching to our food chain. We do not know what we are eating, how much pollutants and contaminants are there, we do not know. So if we talk of the soil health, what is that? Where are we standing? Do we have a policy for monitoring pan-India soil health periodic intervals? Now we say every 3 years we'll do. Very recently we started doing. But is this we are going to do every time? Are we going to invest such huge amount? 5,000 crores rupees, 6,000 crore rupees every year? Is it possible? Then how does this soil health card, it helps in soil health assessment? Is it really an assessment of soil health? Then what should be done to improve the soil health card? Some of the research questions you can immediately take up as a faculty member, as a student of the university. You can consider these topics for your PhD research or MSc research. Defining soil health. How to define? It's not prescription of soil fertility. This much nitrogen, phosphorus, potassium, calcium, magnesium, sulfur, this much. This is not the definition of soil health. Soil health has different dimension, whether it's biological, physical, chemical. So all together, comprehensively, we need to define the soil health for Indian context. Are we going to take the spatial variability into consideration? Are we going to develop some land use, land cover plans for this? How this data will help us? This is another topic. Then within this, the sample collection protocols. The same protocols will valid for crop, same is valid for orchards, same is valid for hills, same is valid for plains, same is valid for rainfed, same is valid for irrigated, or some kind of different protocols required. This we have not told to the government yet. And this is the responsibility of soil scientists in this country. We will tell these things. Nobody else can say these things. There is a way to reduce the burden of large number of soil samples in laboratories. Because the way we are doing now, by simple statistical techniques, we can certainly reduce the total number of samples being collected for analysis significantly. And what is the readiness for soil health assessment on science, technology, infrastructure basis? Do we need to readjust our farm recommendations? So these are the questions which need to come from higher education and research in NRM. Another support is spectroscopy, the new area of research. Spectroscopy, whether infrared, near infrared, far infrared. So last number 5 and number 6 I have shown here. All we tried, 1, 2, 3, 4, 5, 6, we tried in this country. Abroad also we tried. But for Indian context, for Indian problems, now we have concluded that number 5 and number 6, they give better response. That is mid-infrared and microwave remote sensing. And to some extent, number 4 also, visible near infrared. So VNIR and MIR, these are the two techniques. And in both the techniques, while working, we have seen they give much better results. And we are doing some advanced kind of work in this. Our institutes at Bhopal, Institute of Soil Science, then Indian Agriculture Research Institute, and many other laboratories, they are doing wonderful work in this line. The National Bureau of Soil Survey is working in hyperspectral remote sensing. Based on our work, what kind of results we have achieved at Indian Institute of Soil Science Bhopal, if you go for MIR spectroscopy, it is possible to go for very quick estimates of pH organic carbon. Since organic carbon is there, we can link it to the total nitrogen also. And then textural analysis, clay, sand, silt content. We have seen that this technique may not be giving very good result for phosphorus and potassium, but we are still trying to improve these results, supplying our crop responses with the MIR spectroscopy data. And I'm very sure and confident that we are going to achieve this in coming future. We have tested it in alfisol, it gives perfect results. In insectisol, results are to some extent they are good. And in vertisol, we require further standardization. Another area, sensors and precision farming. In soil research, the use of sensors is increasing day by day. In this program, they are also involved in developing some precision farming tools and precision sensors for irrigation purposes, for unmanned aerial vehicles that I will cover later. But before that, another area, when we talk of soil, so we are talking of the soil maps as well. And the kind of mapping we did in this country, we started with 1:250,000 scale map. Earlier that, we went for 1:1 million, 1:10 lakh, means 1:1 million. 1 million scale map is also there. Then we came up with 250,000 map. We came with 1 lakh map. Then we went for district mapping with 50,000 map. And now we are doing efforts for land resource integration at 1:10,000 scale. This is almost every field will be mapped. Almost what we call in Maharashtra Satbara Cha Utara. As per that Satbara Utara or some revenue maps, you can match them and you can give the farm level prescription. You can give the farm level land use plan if you do it correctly. And therefore, some of the automation techniques, whether landform analysis, whether other LULC, what we land use land cover map analysis, we are applying these techniques to this. And also, we are combining our legacy data and we are using this latest remote sensing data and combining them together. And with joint effort, these combined maps, one Goa example I have given in the bottom left side. This is example of Goa. We corrected the landform maps and we imposed our latest remote sensing imagery and we predicted the soil map of Goa. And this prediction is nearly perfect. I don't say 100% perfect, but nearly perfect. With this kind of technique, we'll be able to do in quickest possible time the whole country mapping, and then time and again we need not go for investing such a big amount for soil sampling and soil survey and the soil health management. The unmanned aerial vehicles, the drone technology, what we say, the spraying, mapping, then many robotics we are doing, and MPKB is coming forward in a big way. The left side, this is from CAST CSWM project, who is sponsoring today's program, who is arranging today's program. They are working on this. And in the first week of September, on 9th of September, I think, 9th of September, the Indian Society of Agrophysics, they are organizing one-day training program on drone remote sensing in agriculture. In this program, probably 2 or 3 faculty members from abroad, they are participating, one from Israel, one from US, one from Germany. So my request to my young colleagues, young boys and girls who are listening to this, please don't miss this program. This is being organized by Indian Society of Agrophysics. I have given the link here. You can click through your mobile or you can go through the website of Indian Society of Agrophysics. You will find the details. This is very, very important program. I was talking of fertilizers earlier, and if you see, I will not discuss much on this. I have given some figures. 400 million ton food grains by 2050, we require 60 million ton food grains. 60 million ton plant nutrient to produce 400 million ton. And for that, what is our preparedness? Just see, on 2017, these India, China, USA. These are the three countries, and India, China, USA, Brazil, whether consumption and production is considered. So consumption is, these four countries, they compete with each other because they have large cultivated areas and large nutrient requirement. So these four countries, they keep competing each. The figures of China. China figures for all the fertilizer, nitrogen, phosphorus, potassium. China figures, consumption is less, production is more. So almost all the fertilizers, they are producing for export. And in our case, production is less and consumption is more. That means we are importing more import fertilizers. And this intelligent move of China, they are earning a lot of money because of this, and we are investing a lot of money, and this is creating more and more burden on the government shoulder, because 88% is urea, and most of the urea fertilizer are highly subsidized. The rate of 1 kg of fertilizer of urea may be roughly per kg, rupees 20 per kg. But at what rate it is available to farmer? It is for 5 rupees 50 paisa. It is available to the farmer at the rate of 5 rupees 50 paisa. So for 1 kg fertilizer, government is shouldering 14.5 rupees per kg of urea fertilizer. Forget the other fertilizers. So total burden is very close to 90,000 crore rupees every year. Now, in seconds, just see, globally also, nationally also. If you see the fertilizer product, it is the urea. So nitrogen, source of nitrogen is urea, source of phosphorus is DAP, MAP, and source of potassium is muriate of potash or sulfate of potash. But if you see the reason-wise balance of these things, you will find in Asia more and more dependence on urea. Not Asia, but India, roughly 81% is urea. And in other countries, the dependence on urea is less. They are dependent on other sources of nitrogen, which are more efficient. Because urea efficiency, you know, it doesn't go beyond 40% with all possible means and attempts. Therefore, more and more we are using urea, more and more we are putting ourselves in problem. Now in this graph, right side, fertilizer consumption of selected countries. You will find that the world consumption is 125 kg. Korea's consumption is roughly 450 kg. Egypt consumption is close to Korea. China also consumes more. Bangladesh consumption is much higher. India, this is gross I have kept here. Otherwise, it comes to 1. So, 140 kg per hectare consumption is not very high compared to other selected countries. We say we are using a lot of fertilizer, but really we are not using a lot of fertilizer. Just see, left side, I have given the high fertilizer consuming states, and right side, I have given the low fertilizer consuming state. Earlier, we used to blame Punjab and Haryana. Now you just see who are the more consuming states. This kind of imbalance. And another story, I would say, just see what I have written here. If you see this bottom, 85% of the total fertilizers are consumed in 290 districts, and remaining 15% fertilizer is consumed in 450 districts. So 290 districts, they are consuming 85% fertilizer, and remaining 450 districts, they are consuming only 15% fertilizer. And in this country, we talk of fertilizer movement. This state has got fertilizer, this state did not got. All these things are there, but reality is this. Unless we understand this, we cannot understand the table given above. It shows the table above, it shows the fertilizer use, kg per hectare, and the NPK ratio, which we ideally say that it should be 4:2:1. Except the East India and some parts of South India, you will not find this ratio intact. It is much deviation for 4:2:1. It shows that more and more consumption is happening in the given state where the ratio is distorted or skewed. Organic waste, we are talking of organic fertilizers and organic agriculture. So what is the situation of organic waste? Organic waste situation is not very good. It is not that a lot of organic is available for going into organic farming, although potential is there, but utilization is questioned. Similarly, if we talk of 2050 scenario, where we will require 60 million tons, how much organic is possible? How much organic supplementation is possible? If you want to reduce the dependence by 25% on fertilizers, or reduce the dependence by 50% on fertilizers. In both the situation, the organic supply, we need to rethink. Organic supply means you need to go for enrichment of organic materials. You need to go for some other alternatives or innovative materials. Another options could be nanotechnology. A lot of research we are doing, so we did, and we found that there is a possibility of nanofertilizers, particularly in the micronutrient area. Although some companies, they are claiming so many things, but that requires countrywide testing. And also we need to understand, if you want to really use this urea or nitrogen fertilizer, then in normal shape, they will not go. You need to go for some encapsulation, and encapsulation will be possible through LCPC, what we call the clay polymers, or another technique is nano emulsion fertilizers. This is possible if you want to go in this nano fertilizers or applying nanotechnology in fertilizers. Other areas for nanotechnology in NRM are the nanosensors for pollution avoiding. To sense the pollution, then immediately nanosensors are available. They can help us to immediately understand and ascertain the effluent use, industrial effluent use, and soil remediation. And also the bioremediation or microbial bioremediation of wastewater. This nanotechnology area offers a lot of scope. Similarly, increasing water use efficiency. Now, a little bit of the water sector. Increasing water use efficiency is one such urgency for the country, which requires immediate attention of the policymakers as well as the farmers and everybody. If you want to do, you need to go for some precision technique. Without precision technique, you cannot do this. With the traditional technique, you cannot save irrigation water. And if you want to go with the traditional technique, probably you will not be able to do justice to this country, and we cannot give the intact green resources to the future generation. Water use efficient technologies, small and marginal landholders, big technologies will not work. With all our efforts, micro irrigation could spread only up to 10 million hectare area till now. And we have much area to go, and big areas in Eastern India, and you cannot advocate or you cannot recommend such intensive or very costly technology. So simple technology which can help. I have given a few examples. Such kind of examples are existing everywhere across the easiest possible solutions which we can give to the farmers. A lot of work in this country for last so many years. Dr. Prabhakar Nanda and all my water management scientists are sitting in this gathering. And I tell you that AICRP and water management has done so much so, and a lot of work has been done, and techno-economic feasibility of drip it has been given in depth and dimensions. MPKV is part of that, and many centers across the country, 35 centers across the country, they have shown the advantage of these systems and how to bring more and more area under this. That is a challenge, and that will be future requirement. Let us have a look on government's program. Is that government is not doing anything? What government is doing? So government is doing so many things. What they are doing in the sector of water, what they are doing in the sector of soil. First we'll talk of soil. Then IWMP was the oldest program through which reclamation remediation was possible. Then came National Mission of Sustainable Agriculture. And these are very important programs, and their mission documents are available on the website. My request to the students, please read these documents, because what we study in the university, what our teachers they taught us, those things are different, but the real ground challenges are different. those challenges are enumerated in these documents, which are freely available on the website. The National Mission for Sustainable Health, Soil Health Card Mission, then Paramparagat Krishi Vikas Yojana, in which organic farming is promoted, biogas and manure scheme, then nutrient-based subsidy. You will get a lot of stuff to read, and you will be able to understand how government is serious in this and how much input at the highest level, whether it's DDG, ADG or Vice Chancellor, how much input has gone there and how these robust documents are prepared. Similarly, in the sector of water, whether AIBP program, now it is subsumed with the PMKSY, Pradhan Mantri Krishi Sinchai Yojana, CAT-WM program, then repair, renovation, and restoration of water bodies, highly relevant for water bodies, more relevant for Karnataka, Tamil Nadu, and the eastern states where pond-based irrigation is practiced. Then artificial recharge of groundwater. These are the scheme, lot of investment every government is doing. Government of Maharashtra, Jalayukta Shivar. I don't know how many of you have read the document of Jalayukta Shivar. Wonderful document they have prepared. They have prepared the action plan, district-wise, block-wise. Lot of information is given. Similarly, National Mission on Micro Irrigation, earlier it was, now it is subsumed with the PMKSY, more crop per drop. So these are the things which provides a lot of insight to you. Please go through, and these are the priorities of Government of India, investing huge amount for the development in soil management and developments in the water management. Coming to the third part of my presentation, that is climate change. Sorry, I'm taking a lot of time, but this will be very informative for the for our students. You know, and you will be able to read these things, and the IPCC 5th assessment report, a lot of things are given. The carbon dioxide concentration crossed 400 ppm. Then the methane concentration has already gone up to 1800 ppb. Then third important issue is nitrous oxide. But globally, if you see, we are emitting 3,600 billion tons of carbon dioxide every year. This is a matter of worry. The Indian scenario, Chaturvedi's paper published in 2012 is really a guiding paper, and it gives the variety of scenarios. Different scenarios, CMIP 5 is a model for your information. CMIP model 5, it provides different scenarios. Scenario number 6 and 8.5, they are business as usual scenarios. Means you don't go for any adaptation and mitigation options. Scenario number 4.5, it is the realistic scenario which gives today's situation and which also talk of today's capacity, adaptive capacity. Means for combating climate change, we are doing some efforts. Considering and taking into account those efforts, we still find that temperature in 2030 will rise by 1.8 degree. In 2060, by 2.5 degree. In 2080, roughly 2.9 degree. So these kind of trends are there. These kinds of projections are there. And this projection shows that there is a need to do urgently something so that we can combat these things, and we will be able to retain the temperature under control. And our commitment we will reduce the emission by 20 to 25% by 2020. 2020 now running. This was our commitment, and this is 20 to 25% of GDP. India has already achieved the mark of 23%. So almost 100% target we have achieved in this. So this kind of adaptive and intensively adaptive work we need to do in future. The integrated farming systems, which provides better solution for the problems which I have discussed earlier. Low emission, then the low energy requirement, all these things, and this kind of systems we have across the countries. We have developed roughly 61 models now, and they are suitable for 26 states. And 3 states, namely Kerala, Tamil Nadu, and Jammu and Kashmir, they have already adopted this, and they started their own schemes on this. The other states, they are also looking forward, and they are preparing their schemes. It helps in improving the cropping intensity, nutrient built up in soil, the biological nitrogen fixation, and also enhance the resource base and provides better risk support to the farmers. And percent saving in market inputs, if you see, farmers can save up to 70% of inputs. They can reuse their inputs in the system there itself. And this needs to be taught to the students through research, through education, and to the farmers by extension, and by developing some business model, involvement of young youth at the rural areas, and improving the income. This is the best possible way to double the income of farmers. Some of the examples I have given, I'll not go into detail. For northern region, eastern region, western region, southern region, everywhere if you find, there is the income flow is very regular. Previous to previous, this in between, I have shown the Bihar model, which shows that every month farmers going to get regular income. And in this, if you see, everywhere, every day, farmers get better income through these models. Kahan pe aa gaya bhai? Just wait. Every day, 650 rupees every day, 550 rupees every day. So this kind of assurance is there. Similarly, North is the IFS, and we have seen in different places, this is carbon neutral or emission neutral option. No emission, everything is negative. Similarly, if you talk of the energy efficiency, for 1 joule investment, you will get better output. If you go for rice system, for 1 joule investment, you will getting less than 1 joule energy. But in other cases, energy you are getting is more than 1 joule. So similarly, sustainability, we say 0.5 is the correct sustainability level, or 0.5 is the minimum sustainability level. In all the IFS systems, we are maintaining the sustainability at more than 0.5. So another option is organic farming. And we talk of so many things of organic farming, and we say that organic farming is a better option and better food, healthy food for healthy people in future, because it has so many qualities. But how much is the possibility of organic farming? What are the areas? So niche area and niche commodities we recommend from ICR side, from university side, but we do not recommend this for everywhere and all the parts of the country. Similarly, sustainability is very high in organic farming. Organic farming systems, integrated organic farming system. Sikkim is very well known. This one example just I have shown. Everywhere if you see input and output, output is much higher than the input. Whether system profitability or total energy, everywhere you will find output is much higher in the case of organic farming. This is example of Sikkim. This is example of Meghalaya, where 78% market saving is there. And you are able to create 265 man days per year. That means whole day, one person can be get involved, and sustainability is very high, 0.9. So some of the options can be taken up for the experiential learning, for higher education. For experiential learning, students can be involved in organic farming as well. And some of the very good examples are there in the country where this is happening. But you need to provide, government need to provide some hand holding to the farmers. Otherwise, it is not possible. And hand holding is possible through medium-term loan and through some short-term loan. Medium-term loan, NABARD and other agencies, they are ready, and in a cluster approach, they are providing loan for this. And Kisan credit card at 4% interest, this Kisan credit card, recurring cost is possible to provide. And involving all this kind of capital investment, one can develop a very good kind of integrated farming system model, at least for the demonstration at the block level, so that other farmers can get benefited and they can get attracted to this. Aggregation and value addition, in which our young entrepreneurs, young boys and girls, they can involve themselves. They can develop the kind of Uber model, Uber and Ola model, they can develop for the mobilization of rural youth, for aggregation and value addition of these products in organic farming. The climate risk assessment I was talking about, this is very important. In India, we have done this assessment twice. In 2013, we have done the assessment and we came with the Vulnerability Atlas of India. And very recently, when 5th report of IPCC came and they have defined vulnerability in different manner, then we took the advantage of that definition and we again reworked our risk assessment theory. And now we have developed our risk assessment atlas, our climate risk atlas. And we have divided the 09 districts under very high risk. Now, risk is defined in terms of vulnerability, exposure, and hazard. So when we talk of vulnerability to climate, exposure because of the high population, high dependence on the agriculture, and hazard, the future hazard, have two different options: adaptive capacity you have developed and how much sensitivity you have for the climate change. And accordingly, you go on creating the interventions. So likewise, if you see for the Maharashtra state only, so Maharashtra, you have two districts under very high risk zone, that is Nanded and Bid. Then high risk districts, the 11 districts, Nandurbar, Akola, Washim, Varda, Chandrapur, Hingoli, Parbhani, Jalna, Ahmednagar, Latur, Osmanabad. These are the high risk. Likewise, we have prepared this map. And what are the drivers? Drivers of climate change risk, mainly drought. Then low rainfall, low irrigation, and somewhere the important factor is increase in drought proneness. So these are the some problems, and from that point of view, government of Maharashtra has started Nanaji Deshmukh Krishi Sanjeevani Prakalp, or POKRA, to develop the climate resilient villages. 5,000 villages are to be equipped with the all modern climate change facilities. Jalayukta Shivar Yojana, by which a lot of groundwater conservation has happened, a lot of water conservation has happened, a lot of area under irrigation came, and better support to the farmers came. Hivre Bazar and Raiganj Shiddi are two unique examples which make Maharashtra different than the other states of the country. So this kind of model needs to be replicated everywhere, but unfortunately in this country, people are not learning lessons from these two models which are available and which are the really path-breaking and torch-bearing models, and this needs to be replicated everywhere. Through our NICRA program, we have demonstrated so many technologies which are climate resilient technologies, and in almost all the climatically risk districts, Ahmednagar, these are the villages, Nirmal, Pimpri, Pimpri Local, Adgaon, Budruk, in Amravati, Durgapur, these are the villages where what we have done. And for what we did, for vulnerabilities of drought, heat wave, water stretch, heat wave, and these are the interventions we have demonstrated. They were very, very successful. Farmers are very happy, and these interventions are being demonstrated for now. In future also, we'll keep on demonstrating Aurangabad, Buldhana, Jalna, Nandurbar. This presentation will be recorded there. If somebody wants, they can get the information from Krida, Pune, Ratnagiri. So this kind of work we did, and in this country, through KVKs and through universities, we need to do and intensify this kind of work for future use. The crop residue burning is yet another topic, and MODIS data is being used. And using the MODIS data, we are able to compare year-to-year burning incidences. What happened last year? What happened this year? What happened 4 years back? And you can compare 1 year with the another year. And we are doing so many interventions for reducing crop burning, but monitoring aspect, which is the researchable issue, which is the issue to be taught in the colleges and in agriculture universities. So this is one thing where MODIS data is used, and using the MODIS data, we are able to do this very intensively, very carefully. The kind of facilities we have created in this country are unique. These are no less than any international climate management program or climate management or climate research programs. So we have all the facilities, whether phenomics, whether OTCs, phase system, FATE system, rainout shelter, and you will find that this kind of facilities, IRI, Krida Hyderabad, NRRI, Cuttack, then you have been very close to Rahuri's, our Baramati Institute, there also we have phenomics. So these kind of facilities there, and you need to take full advantage of these facilities. Students for MPKB Rahuri, if they go and work in our Niazam Institute at Baramati, you are welcome. And this work can be done not only in crop sector, but crop, livestock, fisheries, horticulture, soil, water, pest and diseases, all the sectors. You can do the climate research. The simulation modeling in climate research is very, very important. And using the simulation models in wheat and rice, we have given so much projections, and our projections are almost true at short range, at long range also. And we have seen Haryana, Karnataka, Kerala, we have given very good projections. Similarly, InfoCrop, so many crops we have done with the InfoCrop model, and this InfoCrop model, crop modeling is very famous, and many programs are being conducted in IRI, in Krida, and so many other institutes. The varieties, although it's not subject of discussions today, but green gram, rice, These are the varieties which are coming from our national innovation in climate resilient agriculture. These are the current NRM topics which we are doing in NRM through NICRA, and shortly we are inviting the proposals in competitive grant. This for funding, we are inviting the proposals. Some of the theme areas are given here, but more better areas you can choose, and you can come for the funding in the fundamental parts of NICRA. Some of the good happenings in the climate research front is the impact of carbon inputs on soil fractionation, and soil carbon fractionation was known, but how to link with the major nutrient. And this one experiment we have in CSSRI Karnal, and now this experiment is roughly 15 years experience. So after 15 years, what is happening? So over the period of time, what is happening to nutrient management, what is happening to carbon inputs, how carbon dynamics is changed, and how carbon sequestration is taking place is given in this one of the very recently published paper in scientific reports. Similarly, waterlogging in coastal salinity management, very difficult, very, very difficult. This is the information from Sundarbans, the 24 Parganas district of Sundarban, West Bengal. And here, if you want to do this kind of research, you really require a lot of patience and good kind of academic exposure, then you can go for this kind of research. And this is a wonderful area. Similarly, one paper published on the biochar modulated soil condition and the improvement in nutrient dynamics. So these give the pathways to climate change mitigation and global food security. So these kind of papers are coming up, and this is possible through high-end research. And these are the areas for the higher education in soil, climate, water researches. Another scientific reports, the signal of selection in the mitogenome provide insights into adaptation mechanism in heterogeneous habitats in a widely distributed pelagic fish. So whether inland fisheries or marine fisheries, the climate change expertise, simulation modeling expertise is being used in all the sectors. So it is not that NRM means we are not limiting ourselves to NRM. GHG emission, different platforms are there, although we do not have big network of AD towers, AD covariance towers, but whatever we have, based on that, a lot of work on GHG emission has been done in different nutrient scenario, different irrigation scenario, different rainfed scenarios, and then different input management scenarios. So we have come up with very good information on GHG emissions from different systems. Similarly, comparative assessment of urea, briquettes and pre-yield urea and normal urea and its impact on greenhouse gases. This is also studied in depth and dimension and published very recently. I was telling you the ICR80 flux network. If you see globally, the other countries, they have very big network. And if you see the tiny presence in India, we do not have more than, in ICR at least, ICR, we have only 2 AD towers. Only 2 AD towers. One at IRI and one at NRRI Cuttack. But other towers which are available with the ISRO, they have 9 towers. ISRO, NRSC and IIRS, they have 9 towers. Then MOES and IIT Mumbai, they have, IIT Madras, sorry, they have 2 towers each. So if you link all these, then we will be able to probably develop a Indian AD flux network. As a DDG, this is my vision. I want to develop this network so that we can link ourselves with the global network. And once you are linked with the global network, every day you will be getting global information directly on your computers. Similarly, agricultural contingency plans, you are all aware, for every district, through our climate change research, for every district, we have come up with the district agriculture contingency plans, which tells that what is happening with the onset of monsoon. If monsoon delays by 1 week, what happens? Monsoon delays by one week, 2 weeks, 3 weeks, what to do? These kind of advisories, if you want to provide to the farmers, then we need to have this kind of plan. This we have. Anyway, this is another story. I will not. But coming to the our climate change research and involvement of students in this research, which is leading to higher education. I have given the list of universities. A list of is our ICR Institute, where so many research fellows, they are working in this project. they are now well equipped with the climate research technology and climate adaptation technology. And many of them, they are awarded, 87 of them, they are awarded PhD, 18 are pursuing, 40 are awarded MSc, 11 are pursuing, total 150 students. They came out of one project, that is NICRA. And these PG students in different areas, not only NRM, what are the areas? Just see, these are the areas they are working in. So this kind of education is possible. If you have better research facility, you can give better education. This is one example. Dear friends, so these many research fellows are there, and these many RAs and SRFC, such a huge task, huge force. Other than students, already qualified students are there working in different capacities, and they are the future ambassadors in the climate change area. If you talk of higher agriculture education in India, then general aim is to create talent, harnessing demographic dividend. It is not that Jammu Kashmir may have less dividend, Assam has less dividend, Maharashtra will have more. It's not like that. So if you see the present network, out of these 74 universities, ICR is equal opportunity, giving the equal opportunity to all. And we have given the guidelines for minimum standards which are required for establishing any college, whether private college or government college. We have our own guidelines. If you want to have accreditation, one need to fulfill all these guidelines. There is no compromise with the education quality, whether it's admission strength or department or sectional needs or minimum teaching staff, whatever it is. And presently, if you see, we have different programs in 3 categories: education planning, then human resource development, and education quality assurance. Some of the programs are very well taken on the ground, almost all the programs, but some of the programs are wonderfully accepted on the ground, and they are making a lot of transformation in the universities. And I hope you all are aware and you all are taking advantage of these programs. Similarly, ICR provides supports and opportunities to young, talented students and researchers. The international fellowship, Netaji Subhash ICR International Fellowship, 30 fellowships are given every year, both ways. Other country students, they can also come here. India Afghanistan Fellowship, 155. Then India Africa Fellowship, 75 fellowships, mostly for those students coming from those countries. So new students, amenities and hostels, renovation, modernization, and everything is being looked at. Library strengthening, and all possible support is being given to the universities from the ICR side. And this is two-way system. It's not ICR is giving and university is receiving. University is equally producing so much talent and worth appreciating research material, and which is being tested across the country with the support of SAUs. That is the great support from SAU side. And student ready program, which is very, very important program, and many people are taking advantage of our young people. Experiential learning. Many universities, they are doing wonderful work in biofertilizers. Some of them, they are doing wonderful work in biopesticides with the help of students. Students are getting first hand on training there itself. Rural agriculture work experience program, which was there in our time, now completely transformed. Then in-plant training or industrial attachment, this is also happening. Many of our agriculture engineering students, they are taking advantage of this. Hands-on training, skill development, and then student projects. Everything is happening in student-ready program. So dear friends, I have already taken more than 1 hour, this much time I wanted, and right in the beginning, with apology, I said that I will be speaking so much today because I cannot stop when so large number of students are sitting there. Instead of concluding, I just give you the recap of the presentation. NRM presentation cannot be concluded anytime. NRM is such a continued discipline, you cannot conclude anything anytime. So just giving the recap, what we did today. First, we have addressed and defined what environmental sustainability is, how NRM is linked with the environmental sustainability. Then we talk of the sustainable development goals, and I appraised you about the India's commitment in COP14 and land degradation neutrality. Then slowly we came to sustainable soil and nutrient management programs. What are the soil management programs? What is the fertilizer and nutrient management? What are the drawbacks where we need to strengthen? And what are the areas, new frontier areas, where higher NRM education is possible? Then came slowly down to sustainable water management. With water management, I have touched only few issues. I did not go into depth and dimension because people, they always considered me more biased towards water management. So I restricted myself, and so I have touched only few aspects of water management. Then I have also given the government initiatives and programs in soil and water management programs. I also talked of integrated farming system and organic agriculture for future agriculture needs and for future climate neutral or carbon neutral or emission neutral agriculture. Also frontier areas, whether nanotechnology, whether use of sensors or use of drones, all these things we discuss. And a lot of discussion we have done on climate change research, which will be the futuristic research. And then climate smart agriculture, in which we have demonstrated some interventions at the district level and how the rural youth can become part of that, how in Ola and Uber model, they can become the ambassadors and they can provide, they can become backbone of village economy and provide better support. Slowly, slowly, we came down to the higher agriculture education, and I have appraised you what is happening in climate smart agriculture research program, how education is being given, and NRM disciplines which are dying, like clay mineralogy, hydrology, then pedology is also taking a back seat. These programs requires immediate attention. So this way, slowly, slowly, starting from sustainable management, sustainable environmental management, we came down to the higher agriculture education program. Dear friends, I want to conclude on a very touching note. In Maharashtra, there was a saint poet or saint, he was a great saint and philosopher, Sant Gyaneshwara. He has written a very big analysis of Bhagavad Gita, and it is known as Gyaneshwari. In Marathi, we pronounce Gyaneshwari. So in 12th chapter, Adhyay 12th, and it has OV number 8, just like Ramayana and Mahabharata, we have Chaupai and Doha. Likewise, we have OV. So OV number 8, our Mauli says that Manoni Sadhaka tu Mauli, Pike Saraswat Tujia Pauli, Ya Karane mi Sauli, Nasandi Tuji. Right in the beginning, when I say that I want to dedicate this today's presentation to my great university, MPKV, I treat this particular OV in that context. MPKV, where we have learned so many lessons, a lot of knowledge, our teachers gave so much to us. So today, at this occasion, I remember my university, oh my MPKV, you are my mother. Knowledge grows under your feet, and that's why I don't want to go away from your shadow. Be positive, be safe. Thank you so much. And I'm thankful to the organizers for giving me an opportunity to discuss so much so with young boys and girls. Thank you so much.
Thank you, sir, for being with us for this webinar and sharing your knowledge and expertise with us. It will definitely help to GRF, SRF, NET, and ARS aspirants, all the students, faculties, and budding scientists of across the country. Thank you so much, sir. It is humble request to all participants, those who are attending webinar on 3 different platforms, namely Zoom, YouTube, and Facebook. Please fill your attendance by provided link in chat box to ensure your certificates, and it will be valid till 10 minutes after the program. Now I request to all participants, if you have any query or questions, please drop into the chat box. Thank you.
Thank you, Neelam. There is one question from Abhay Sani. He is asking how to decrease water usage in livestock farm.
Good.
Hello.
You can take any associated question if any other question is there associated with this. So,
okay. There is one question from Rishitika. What are the future prospects of career in NRM in India?
The first question is different from the second. I thought maybe linked question. Okay. So when we talk of reducing the water footprint from livestock, you need to go for small innovations. Like NDRI has come up with, in our NICRA program, NDRI has developed a small gadget. It has a small valve it is mounted on the same height where the animal's mouth is there, whether it is small ruminant or big ruminant. For big ruminant, different level, small ruminant, different level. So that animal goes and just touches that wall. One lever is there. Immediately after that, water starts coming. The moment animal drinks the water and it removes its face from that, its mouth from that wall gets shut. So that is one way. Secondly, you can reduce a lot of water when you go for animal washing in the shades. So big dairies and big animal shades, you can go for washing with the fine nozzle technique. With fine nozzle technique, the amount which is required normally for one washing of one animal, you can wash 4 animals in the same amount of water. So there you can do 75% reduction. Similarly, our ICR research complex for Goa, and now it is called Coastal Research Institute, ICR Kakari, Central Coastal Agriculture Research Institute. There also we have done some this type of intervention by which we have brought down the water consumption. And now for consumption of water by animals, I'm giving you tips of avoiding the water losses. Consumption cannot be brought down because consumption, whatever is required, whether it is desi breed or exotic, whatever it is, we have to provide the water as per their consumption, physiological need. But these water losses can be certainly brought down. Next question.
Dr. U.S. Saika is asking how to keep a balance between sustainable development and increasing food grain demand.
Yeah, it's a very good question. Because it is a kind of trade-off between the development and also the kind of explosion in population is there. Explosion in human and animal population versus the consumption versus the sustainable resource management. It is possible if you go with the theory of restoration, means degradation versus restoration, and everywhere, if you go for better restoration option, you can do this very well. And India has been doing all these things. The past Indian agriculture experience is a great wisdom of this. Our Vedic agriculture is really is a great treasure for this. It is possible to do with the conjunctive theory, whether it's conjunctive use or conjunctive use of inputs. It is possible if you go with the integrated nutrient management or integrated or your conjunctive use in water management, or keeping the adaptive techniques in mind, go for the climate resilient agriculture. Everywhere it is possible to reduce the carbon footprints and also bring down the emissions. Once you do this, then probably you will be make and justify the questions you made, that how to create a trade-off between the new developments and the NRM commitments.
Thank you. Next question is from Omkar Kumar. He is asking, what is the role of soil researcher in climate change?
Yeah, great, Omkar Kumar. Probably I know you personally. Omkar Kumar, really this is a very good question, and our soil science friends, they probably understand that they don't have any role in climate change. It is not that. Whether you are soil water engineer, agronomist, soil scientist, or crop physiologist, you have a role to play, because everything is happening on the surface. All transformations are happening on the surface, whether climate change processes, their modeling, or coming up with the intervention, adaptive interventions. Everywhere soil scientist has a role to play. It is not only nutrient management, it is not only soil management, but also overall, if you go for total carbon budgeting of the whatever climate resilient model you are involved in, the role of soil scientist is very, very important.
Thank you, sir. Next question from Bhagyashri Solanki. Sir, as a soil health card, is it need of this area to assess the quality irrigation water also to be used for irrigation? Is any government policy is present for there for this?
Shubhangi, क्या नाम पता है? Shubhangi?
Yes.
Shubhangi, see, water quality testing, like soil test testing, I think it is required, but not intensively at the scale which we are doing the soil testing. Why? Because if you see the area irrigated, number one, 50% irrigated area. Within that, roughly 60% is groundwater irrigated. Quality question comes only for the groundwater. And groundwater, if you see the groundwater quality map, which was prepared earlier, and the CGWB data, Central Groundwater Board data, it shows that there are the pockets where the underlying water or groundwater is poor in quality. Now, poor in quality, when we say, we essentially mean that we go for sodium absorption ratio, total electrolyte concentration, or EC, pH, SAR, ESR, likewise, SAR and adjusted SAR, all these things. But this much is not required. Wherever poor quality water is there, only those area testing is required. Secondly, some areas in the eastern part of the country where arsenic laden water is there, arsenic, fluoride, these two specific ions requires testing. Otherwise, no specific ion requires testing. Therefore, the groundwater testing is relevant only for limited areas which need to be identified first. If water is problematic, then only go for testing. Otherwise, don't make unnecessary investment or expenditure.
Thank you, sir. Next question from...
There are many queries in the chat box. I think what we should do, we should copy those queries by their name and then consult our chief guest to answer those queries to the respective participants. Okay, and we'll take a few questions from the raised hand category. Ashok Kumar, who is SRF at TNAU, we have unmuted you. You can ask or you can raise your queries crisply and precisely to the chief guest. Yeah.
Sir, good afternoon, sir. Thank you for the wonderful session. My question is about soil microbial diversity, sir. You said that nitrogen fertilizer has more impact on changes of imbalance in diversity. What are the other fertilizer roles, sir? Is there any other fertilizer cause any exploitation on microbial diversity?
Okay, Ashoka, thank you very much for raising this question. Let me tell you that any chemical, not only fertilizer, any chemical, because of its chemical nature, is sufficient enough to create damage to the tiny microorganisms. Whether it is fertilizer or pesticides or herbicides, or it is nitrogen fertilizer or phosphorus or potassium. The beauty of phosphorus fertilizer is it is immovable. It gets fixed wherever it is. Either it is available to the plant or it gets fixed, or through runoff it gets washed out. The potassium is so mobile, so quickly, either it is taken up or it is moving downward. Therefore, the resident time which is in contact with the microorganism is very low for potassium. And phosphorus itself gets fixed and it doesn't get involved in any of the other processes in the soil. It may not create much damage to the microorganism. It is nitrogen, and since nitrogen immediately get converted into nitrate, so nitrate, once it becomes non-reactive pollutant or non-reactive ion, because the clay is already negatively charged. Nitrate ion is also negatively charged. So it doesn't get absorbed on the clay particle. That's why it is available freely in the solution. And so whatever microorganisms coming in contact with the nitrogen, because of the higher osmotic potential, it starts damaging microorganisms very badly. And this is the reason nitrogen fertilizers, they create more harm to the microorganisms than the other fertilizers. This is what I meant to say. Otherwise, any chemical, presence of any chemical is enough to create damage to any of the microorganisms. Forget about bacteria alone. Any of the microorganisms can be damaged by any of the chemical. But I'm talking very specific about nitrogen because the residence period of nitrogen is highest in the soil, and reactive period of total reactivity, and when it is ammonium form or nitrate form, total potential, osmotic potential period is very high. That damages the microbial population. Yeah.
Thank you very much, sir. We know that this particular expert lecture has generated a lot of interest, and there are so many queries from the participants from YouTube platform as well. But because of the paucity of time, with your permission, we now stop this chart section, our discussion section. I request Dr. Neelam and Dr. Shubhangi to move on with the next program.
Thank you, sir. Thank you so much to all.
Before
Yes.
that, I would say that I will be thankful because all others are my close friends and colleagues. So if I forget their name, doesn't matter. But I want to particularly thank to this S.R. Shedke, Neelam Kondvilkar, Shubhangi Ghadge, and M.A. Tambori for conducting this session so wonderfully. Thank you so much.
Thank you, sir. Thanks for your kind words. Now I would request to Dr. A.K. Patra, sir, President, Indian Society of Soil Science and Director, Indian Institute of Soil Science, Bhopal, for his valuable remark. Sir, please.
अनम्यूट करा त्यांना.
पात्रा जी, आप बहुत स्मार्ट दिख रहे हो आज.
Sir,
please unmute yourself, sir. Please unmute yourself.
Thank you, sir. Thank you very much. नमस्कार आप सबको. Namaskar and very good afternoon to each of you in this very important program. Honorable Dr. S.K. Chaudhary Sahab, DDG NRM, today's chief guest, immediate past president of Indian Society of Soil Science, Honorable VC of MPKB Rahuri, Dr. K.P. Vishwanath Sahab, Dr. A.L. Farande, Dean and Director of Instruction, MPKB, Dr. S.R. Gadak, Director Research and Director Extension Education, Dr. Deepak Viswas is also with us, Secretary ISSS, Dr. B.D. Bakreji, Organizing Secretary, Dr. S.D. Gorantikar, Convener of the program and Principal Investigator, Dr. M.C. Ahire, Associate Dean, MPKB, Dr. N.J. Ransur, Secretary, Rahuri Chapter, Dr. Shinde, Dr. Selke, Dr. Kondvilkar, Dr. Shubhangi Ghadge, and all other colleagues, all faculty members, resource persons, trainees at different locations, esteemed members of the Rahuri chapter of Indian Society of Soil Science, RA, SRFs, farmers, NGOs. I know in this lecture, many people are there at different platforms. Dear students, ladies and gentlemen, it is indeed an opportunity, a great opportunity and privilege to join you and greet you. On my behalf and on behalf of our institute, Indian Institute of Soil Science, Bhopal, my hearty welcome to each of you. I am really highly thankful to the organizers, ICR National Agricultural Higher Education Project, Center for Advanced Agricultural Science and Technology for Climate Smart Agriculture and Water Management, and Rahuri chapter of Indian Institute of Soil Science for inviting me in this very important and excellent program. First, I must express my feeling about the outstanding lecture in this morning from our Honorable DDG Sahab, today's chief guest, at his alma mater. I must say that on NRM such lecture is rare. It was an watershed lecture where everything A to Z of NRM, soil, water, air, climate, biodiversity, all in agriculture, horticulture, livestock, fisheries have been so well covered in a perfect manner. He covered outstandingly, convincingly, in so simple a way. I'm sure each of us become much wiser, much enlightened on NRM for education, research and extension. Emerging challenges of NRM in the international and national context and the ongoing programs at the international or national levels, policies of the world, all have been covered. nothing is left virtually. So, all the current NRM challenges, as you all know, as our Honorable DDGs have listed and so nicely explained, that these challenges are enormous at the present time, and also it will be in future, because our resources, NRM resources, are limited. I'm not going to repeat all those things, and I cannot also. So he also given the major focus that the increasing farmers' income, how to use traditional and new science, deeper science at local and national perspective for managing the NRM. Really, this was a wonderful lecture, which was so intensive as well as extensive, I should say, on NRM, covering all aspects for research, education, and extension. And I'm sure each of us, particularly the student friends, MSc and PhD, who are developing their career in any field, whether for becoming scientists or administrative services, it will be so useful and helpful. I'm sure many of you have got motivated also and inspired by working in NRM, being at any position, whether you become an administrator or scientist. I request our Honorable DDG Sahab for kindly accepting for such lecture in all universities at different platforms for different stakeholders. This will not only enhance intensive sustainability of agriculture, food system, and environment, but also enhance high quality human resources, which is the main natural resource, I should say. You know, the future green revolutions will be soil centric, NRM centric, not seed centric. That cannot be. And this lecture is an eye opener. I congratulate the Honorable VC Sahab and each of the organizers for your great vision and pioneering action to march in that direction. Thank you so much, each of you. From core of my heart, tomorrow is Independence Day. Wish you 74th Happy Independence Day. All very best wishes. आप सबको नमस्कार, जय हिंद.
Thank you. Thank you so much for your valuable remarks, sir. Now I request to Honorable Dr. KP Vishwanatha, sir, Honorable Vice Chancellor of MPKV Rahuri, to enlighten us with your words. Sir, please.
Good afternoon, everyone. The proud alumni of MPKV and today's chief guest and Honorable Deputy Director General of NRM ICR, Dr. S.K. Chaudhary ji, Dr. A.K. Patra ji, the President of Indian Society of Soil Science, and the Secretary, Dr. Bishwas ji, and all the scientists from ICR, all my colleagues from MPKV, both our directors, Dr. Gadak, Dr. Farande, Dr. Gorantiwar and his CAST team, and Dr. Bakre, organizing secretary, all the associate deans, HODs, faculty, scientists, and students who have joined not only from Maharashtra, but across the country in 3 different streams, both in Zoom, as well as the YouTube and Facebook. I could see almost in Zoom only, there were around 550 participants had reached at one time. I think now the number is coming down, and I will just close before the number comes down, still comes down. I want to sum up whatever this one. Friends, you all agree what an exhaustive presentation made by our proud alumni, Dr. Chaudhary ji, an eminent soil scientist of the country. And also, as Dr. Patra ji mentioned, it is A to Z. That is, he has covered threadbare, everything, covering the national research priorities in NRM division and the government interventions and with all the very good data and statistics, I am more happy because he stressed the importance of microbial diversity. Almost since 5 years, I have been, whenever I used to address soil scientists, I used to mention, you are forgetting microbes, you are forgetting microbes. And in the last 1 decade, this is my 43rd year after my master's, but I have been fascinated by this element, the great element, that carbon, 6-atom carbon, from graphite to diamond. And though I am a plant breeder, I learned and I studied more about this wonderful element. And being a plant breeder and geneticist, I have delivered few lectures on the role of carbon in environment and agriculture. So that has been fascinating for me, because in our early stage of our career, we did not realize the importance of the NRM or carbon or the soil fertility or the soil health, all those things. Because being a breeder, we were used to focus only on crop improvement, enhancing the yield of all crops. I think all the agricultural fraternity, we have done one great mistake by ignoring during our Green Revolution period, only focusing on yield, ignoring these two important elements, especially the soil. I think it is very touching and heartening to note that the soil carbon, average soil carbon of Indian soil was around 2% in majority of the cases before Green Revolution. Now it is far below 0.5% in most of the soils, and even some degraded soils, it is not even 0.1, 0.2%. So my concern have been, friends, in the last 2 years, Honorable Finance Minister, you called for the consultative group meeting before the budget. I mentioned both the years this particular importance of the carbon, the content, reduction of carbon content in the soil, because in future, not only the environmental sustainability, in future, if at all you want to feed this whole growing population, you need to maintain the soil health, because it is not the genetic material that is we are breeding, it is not important. As all of us know, it is G into E, and E takes major role in this. I quote one example. The same 8332 sugarcane variety, which is almost 20-25 years old variety, and the farmers have harvested highest record yield of 138 tons per acre to almost 160 tons per acre. That means to say, the genetic potentiality being constant, with the environment, you can enhance the productivity, or you can increase the productivity. And in future, the focus of research should not only focus on crop improvement and developing climate resilient varieties. That is most needed. And I'm very happy Dr. Chaudhary ji has touched all the important aspects, not only research, even experiential learning for the students, and also the government policies, what we are doing. This most important thing is, I don't consider the only soil scientists or engineers or only NRM people should know about it. Any agricultural scientist in this country should know the importance of soil and this natural resource management, and we should give this importance. And see, in future, if at all we need to, so that was, I was mentioning, after Green Revolution and also after urbanization, all the biomass that is being produced in the rural area is going to the urban area, either to city, a district headquarters, or towns, or the municipalities, or this one. And only NPK is coming back to rural area in terms of fertilizer. Very little, I think maybe less than 10% of it is coming back as a biomass. I think there is an absolute necessary. I think it should go as an andolan in the entire country to bring back whatever all biomass that we are shifting by way of food grains, fruits, vegetables, all fodder, feed, everything to the urban area. It should go back as a management, organic matter management, the biomass management. It should go back. And that's why my request to Finance Minister was, why don't we bifurcate some of your fertilizer subsidy towards the compost, this one, and for subsidy should be given, and farmers should be encouraged to enhance the use of organic venue. That was my request. I think, unfortunately, an honorable minister was not there, and it has fallen on the bureaucrats, and it is not being taken. But still, some efforts are going on, but it's not enough. And another thing which I wanted to share with you is the most important thing, the burning of residue. I saw a title, Monitoring the Crop Residue Burning. I say, instead of monitoring, we should ban burning in the entire country. We should, unless you ban it, see, burning, you burn. And if you burn, your carbon dioxide concentration in the atmosphere will increase, and as a result, the temperature will go up and the climate change, and we are seeing, and it is resultant of recklessness. And we should understand what we are doing, the mistakes in our agriculture should be taught to the youngsters, and also we should create awareness towards the farmers. And it is not that they don't know, but they don't know the importance of its severity of the problem. We should create awareness to the problem for the farmers and also young generations. Another thing is, I have been very much impressed about the conservation agriculture. But unfortunately, in India, we are not giving importance to that. My request to all the conservation agriculture, which is happening in most of the developed countries like Canada, Australia, they are giving such an importance. And the conservation agriculture should be introduced as a subject in addition to whether you call it is agronomy and soil science, it is you. But my request is, it is most important, unless we conserve these biomass or whatever all the elements soil by way of all the things which Dr. Chaudhary is mentioned, with all the research, with all the NIRA and all the activities, it is very difficult to ensure the food productivity or food security in future, because the land, the area of land is coming down year after year, and the land is degradation is increasing, and the productivity has to be maintained. To maintain the productivity, we need to control these things. In this context, the lecture given by our the scientist and the DDG of NRM is this one. And this, what I think is, instead of some people are mentioning, this will be useful for our students for the SRF, JRF. No, I don't agree. The SRF and JRF are the byproducts. It is not our game. It is to create awareness in the youngsters to think about the soil, to care, to respect about the soil, and to take care about and to spread the knowledge about the soil. And irrespective whether what discipline he belongs, if he is an agricultural scientist, it may be animal scientist or a plant scientist. If he is an agricultural scientist, I quote, this they should understand the importance of NRM, the importance of soil conservation, and unfortunately, year after year, the floods, and you are watching both is happening simultaneously. And especially this is happening for the last 2-3 years, very unexpected events. And if at all you want to prevent it, we need to be careful about this one. And also, and for the information of also Bhadraji, we have this Hivre Bazaar and Ranegaon Siddhi Mata, we have started in 2017 October with the help of Adarsh Yojana. We have taken up the watershed program in our university campus in E-Block with about around 2,500 acres. And all the work has been done. Now we have started tree planting from this year in those areas. I think that's whatever model it is in the USR and Rank of City, we are trying to replicate and also the epic also, because we have a huge area of is there. So that way it is needed. The statistics which are giving, I am seeing, see the water soil, because of the bad management of water, the irrigation, reckless irrigation, we are losing this soil, and each year we are converting the good soil into bad soil. That way it may be the saline, whatever it may be, the problematic soil we are creating because of recklessness. I think that should be stopped. And I have visited some of the Sangli area. So one of the sugar cane factory, so I think Ganapatra or MLA, they are doing in a community basis. This one, it cannot be done by individual farmers. They are doing thousands of acres in a community basis. We should encourage it. We should bring back this soil of the problematic soil to the reclaim it as soon as possible. I think there are some. I think I'm happy to see that Dr. Chaudhary ji has mentioned a very good initiative, both Jala Shivar and the programs in Maharashtra and the Bokara program, which is doing it. Our university is also involved in Bokara, just one district of our jurisdiction, but it is a need. I think I don't want to take much of your time. I think number of 40, already 200 people have left before some other people left. Once again, I'm thankful to Dr. Chaudhary for a wonderful lecture, for covering all the aspects of the soil as well as the NRM and all its aspects. And also I'm thankful to Dr. Patra for guiding all our scientists and students. And I compliment the past group headed by Dr. Gorantiwa for actually these should have been on in the earlier date. We have this is a postponed one, and because of the other program of ICR, we could postpone it to today. And I join in wishing all the participants and the scientists, Dr. Ashok mentioned tomorrow's Independence Day. Once again, I wish all of you in advance the happy Independence Day of 74th Independence Day of our country, and the Corona. And we have to leave it. Corona will not go easily from us. You have to leave it, and please take care of it. Let us follow all the rules of the social distancing and other things. Let's take care of ourselves and also our children and elders in our family, and let us take care how to work with the Corona. We should learn, and we are also learning. This is one such is the online program which we are having. And I'm thankful to all of you, and thanks to all the participants. And I wish the message should go for the conservation, the importance of soil. And I appreciate the mentioning about the soil health card should find a place. The soil biology or the microbes. There should be some, and it should place. I think in future we will refine our soil health cards based on the recommendations. For that, we need to do some research. Based on that, we will in future we hope to improve upon or refine our soil health card so that farmers also get a first-hand information for the maintaining the soil health. With these words, thank you very much, and thank you everyone. Thank you, Dr. Chaudhary ji, Dr. Patra ji. Thank you.
Thank you very much, sir. Wonderful.
धन्यवाद.
Thank you, sir. You are always been the source of energy for us. Now, I would request to Dr. Sharad Gadak, sir, Director of Research and Director of Extension, Mahatma Phule Krishi Vidyapith Rahuri, to extend the vote of thanks. Sir, please.
Good afternoon to all of you. I am fortunate enough to express the vote of thanks for today's national webinar. In spite of his busy schedule, Dr. S.K. Chaudhary ji, DDG NRM ICR, New Delhi, and alumni of our MPK Rahuri has accepted our invitation as a chief guest and deliver the lecture on higher education and research in national resource management for environmental sustainability. Sir, you have given very valuable lecture to all our staff, students, and our faculty, and it will be memorial lecture, and definitely it will help for all the participants. And on behalf of our university, I am extremely thankful to Dr. S.K. Chaudhary sir for his valuable lecture. I am also equally thanks to our guiding force of university, Honorable Vice Chancellor Dr. K.P. Vishwanath sir, and they presiding over the function and guiding us from time to time for making this webinar successful. And I thanks to Dr. A.K. Patraji, Director of Indian Institute of Soil Science at Bhopal, and President of Indian Society of Soil Science for his valuable remark and actively participation in this national webinar. I thanks to Dr. D.R. Biswas, Secretary, Indian Society of Soil Science, for his active participation. I thanks to my colleagues, Dr. Ashokji Parande, Dean Faculty of Agriculture, MPK Rahuri, for his guidance and sharing his views in this national webinar. I thanks to Dr. D.D. Pawar, Dr. Ranpiseji, Associate Dean, for their presence and participation. I thanks to Dr. Prabhakar Nanda, Principal Scientist, Bhubaneswar, for their presence and participation. I thanks to the S.C. Pandeji, Sanju Sandal, Principal Secretary, Palampur, Dr. R.S. Chaudhary, Bhopal, Dr. S.P. Dixit from Palampur, and Dr. Khodke from Parbhani, and his active participation in this webinar. I thanks to Dr. Nagaraju, Dr. Jangbani sir, and also Baldev Ram for his presence in this webinar. I thanks to all head departments and all the scientists from the ICR Institute of our country, and young scientists also. I thanks to the faculty members for his presence. I thanks to the organizing secretary, Dr. Convener, Dr. S.D. Gorantiwar, organizing secretary, Dr. B.D. Pakre, head departments of soil science, and Dr. M.C. Ahire, associate dean, and Halgaon College, and head department of extension, and Dr. Ranshur, Dr. M.G. Shinde, co-convener, and all his team for their active efforts in organization. And I thanks to all the JRF and SRF candidate for examination they are preparing, and the student of all the students present in this webinar. I thanks to the Rahuri CAST team, member of CAST project, and also Rahuri chapter of Indian Society of Soil Science, and all who have knowingly, unknowingly helped for making this national webinar success. Thank you, one and all. Thank you.
Namaskar.
Thank you.
Congratulations, hearty congratulations.
Thank you, sir.
Thank
you
you.
very much.
बहुत ही अच्छा एक्सीलेंट प्रोग्राम.
Thank you very much.
एक्सीलेंट प्रोग्राम. आप लोग तो एकदम सब कुछ पहले करते हैं, एवरीथिंग फर्स्ट. पहले ये 40 कितना टोटल कितने हो गए? 43. So sir, you are marching ahead and you are guiding other people.
Sir, this is just because of our honorable Vice Chancellor.
Yes. उनका तो है ही, उनका ही तो विजन है, उनका full support है तो भी तो things are going very successfully, satisfactorily and we
Sir,
are really,
काम कोई करता है, नाम कोई लेता है, नहीं ऐसा नहीं. It's all due to our team. We have an excellent team. It is their enthusiasm, their dedicated work. It is the credit should go to them. I am just in forefront. That's all. Thank you.
Thank you very much.
टीम तो डॉक्टर साहब, टीम तो पहले से ही आउटस्टैंडिंग थी ही, बस टीम लीडर की जरूरत थी, वो उनको मिल गई बस.
That is right.
Absolutely right. उसमें एनर्जी पूरा था, इग्निशन का जरूरी था.
Dr. Nanda and Dr. R.S. Chaudhary, they have also joined. Thank you very much, sir.
Yes, I see Bhopal.
Very good. Thank you.
नंदा जी सामने आ जाओ यार एक बार. नंदा जी आपको, हाँ नमस्ते.
ग्रुप फोटो ले लिया आप लोग? ग्रुप फोटो?
Yes sir, ग्रुप फोटो
ले लिया.
Thank you very much. So nice.
बहुत से वाटर मैनेजमेंट के लोग आए हुए हैं इसमें, बहुत से मेनी वाटर मैनेजमेंट साइंटिस्ट.
डॉक्टर पांडे जी है.
सर नमस्कार सर.
नमस्ते, सुरेश पांडे जी दिखाई दिए मुझे.
अभी तक म्यूट करके रखे थे सर. नमस्कार.
डॉक्टर खोड़के is there.
हाँ, खोड़के भी दिखाई दे.
खोड़के ना अनम्यूट करूंगा.
Very good.
Shall we close now? हाँ, खोड़के is there.
अरे वाह. बोला खोड़के साहेब, काय म्हणता? बरं चाललंय?
हाँ, yes. Everything is fine.
परफेक्ट टाइम में आप लोग कंप्लीट किए. हमारे इधर लंच टाइम होता है 1:30.
थैंक यू वेरी मच.
डॉक्टर खोड़के नमस्ते.
आप सबको पूरा
नमस्ते सर.
धन्यवाद, शुभकामनाएं.
हैप्पी इंडिपेंडेंस डे सबको.
हैप्पी इंडिपेंडेंस डे.
इंडिपेंडेंस डे यू सर.
Thank you sir. Thank you very much.
Take care.
इंडिपेंडेंस डे विद सोशल डिस्टेंस.
Yes.
नमस्ते पांडे जी.
पांडे जी
नमस्कार सर. थैंक यू सर. थैंक यू सर. बहुत धन्यवाद आपको. बहुत अच्छा लेक्चर था सर.
बढ़िया सर. आउटस्टैंडिंग लेक्चर.
बहुत अच्छा लेक्चर था सर. बहुत आउटस्टैंडिंग.
अरे नहीं ऐसा नहीं यार, ऐसा ही थोड़ा
सर.
ये थोड़ा लर्निंग फॉर अस.
बहुत सी चीजें. हाँ,
पहले तो मैंने सोचा था कि इसका 50% पोर्शन में मराठी में करूंगा, लेकिन फिर मैंने देखा कि उसका कोई